All right, next up I picked number 5 because it was a little bit different. I wanted to make sure we had some improper integrals in there. We need to determine if this integral is convergent. And if it's convergent, we want to figure out what it converges to. So we've got the natural log of x over x to the 4th. We want to figure out, first of all, what the antiderivative is of this, and then determine if that integral converges. That's going to take limits kind of combined with the fundamental theorem of calculus. This is going to be an integral by parts. Okay, when you see this, I think of that LIATE acronym: logarithmic, inverse trig, algebraic, trig, and exponential. The first thing I see is a logarithmic function. That needs to be u. So if we make a substitution using integration by parts, we're going to let u be the natural log of x. du is going to be 1 over x dx. That means if u is the natural log of x, dv has to be everything else that's in that integral. Everything else that's in that integral is 1 over x to the 4th dx. The antiderivative of 1 over x to the 4th dx, if you want to think of this as x to the minus 4, we're going to increase that exponent by 1. That gives us minus 3, and then we would divide by minus 3 as well. So what that gives us is v equals minus 1 over 3x to the 3rd. If you want to take a minute and confirm that antiderivative, please do that. Okay, so integration by parts. u dv, the integral of u dv, equals uv minus the integral of v du. So we're going to take those substitutions from the previous slide and plug and chug. U times v ends up being minus the natural log of x over 3x cubed. We're going to subtract the integral of v du, which is negative 1 over 3x cubed times 1 over x dx. All I did on this next line was take 3x to the 3rd and multiply it by x, which gives me 3x to the 4th. And then I pulled out a negative 1/3, which ended up making it positive. So now what we've got, the first part minus natural log of x over 3x cubed, we're done with. We don't have to worry about that. We do still have to take the antiderivative of x to the minus 4. That's a simple x to the n antiderivative, so we're going to increase that exponent by 1, x to the minus 3, and again divide by minus 3. So our antiderivative would be minus natural log of x over 3x cubed plus 1/3 x to the 3rd over minus 3. Clean that up a little bit, do some algebra. Here's what we've got. Negative natural log of x over 3x cubed minus 1 over 9x to the 3rd. Now, that's our antiderivative, which is only the first part of this problem. We need to figure out if this improper integral off to infinity from 1 to infinity is divergent or convergent. Okay, the way we're going to do that is we're going to change that upper limit from infinity to some other placeholder. In this case, I used a. And we're going to take the limit as a goes to infinity of this definite integral from 1 to a. To do that, we need to use the antiderivative that we found on the previous page. So now we're taking the limit as a goes to infinity of the antiderivative evaluated from 1 to a. Use the fundamental theorem of calculus. A goes in, 1 goes in, we do some algebra. So this is our function evaluated at a, natural log of a over 3a cubed minus 1 over 9a cubed. This is our antiderivative evaluated at 1. This whole piece over here just becomes 1/9. It becomes 1/9 because the natural log of 1 is 0. So that's what's there. And then in the middle, I just split up and wrote this as 3 different limits because I thought that that would be easier to work with. This one is the easiest one to start with. What's the limit as a goes to infinity of 1 over 9? Well, it's just 1 over 9. The second one, the middle one, is the next easiest. As a gets really, really, really big in the bottom, this whole quantity is going to get really, 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 really small. So that limit's going to go to 0. This one's a little bit more complicated. I'm not really sure what to do with it, but if I plug in infinity, I'm going to get a really big number in the top, a really big number in the bottom. That means I can use L'Hopital's rule. So this limit on the end, that becomes 1/9. This limit in the middle, that becomes 0. This front limit, I'm going to take and I'm going to use L'Hopital's rule. When I use L'Hopital's rule, here's what happens. The derivative of the minus natural log of a is minus 1 over a. The derivative of 3a cubed is 9a squared. Cleaning it up with some algebra, I'm left with the limit of negative 1 over 9a to the third. This is almost exactly the same as what we've got here. Actually, when you put that negative back in, it is exactly the same as what we've got there. That limit is going to go to 0. Everything on the bottom of this fraction is going to get really, really big. So when I take negative 1 and divide it out, it ends up really, really small. So that integral, that limit, is equal to 1 over 9. So this limit, as we work through the fundamental theorem of calculus, we find the antiderivative, we evaluate the limit, ends up being 1/9. So this integral from 1 to infinity of the natural log of x over x to the fourth dx is equal to 1/9. The limit converges, and it equals 1/9.